Hello everyone, welcome to the Betikrame TECH YouTube channel. Today I will show and also describe how we have modified and changed the steam turbine ejector diaphragm. In our factory there are two numbers steam turbine operated generator. A steam turbine is defined as a form of steam engine that extracts thermal energy from pressurized steam and converts it into rotary motion, which is then used to drive an electrical generator. Turbines can be subdivided according to the direction of flow. The three main areas are radial, diagonal and axial, and the flow medium determines which type of turbine it is. The four main types are usually steam, gas, water and wind. An ejector is a device used to suck the gas or vapor from the desired vessel or system. An ejector is similar to a vacuum pump or compressor. The major difference between the ejector and the vacuum pump or compressor is it had no moving parts, hence it is relatively low cost and easy to operate and maintenance free equipment. The operating principle of the ejector is the pressure energy in the motive fluid is converted to velocity energy by an adiabatic expansion in the converging or diverging nozzle. Due to the pressure drop of the motive fluid, it will create a low pressure zone before the mixing chamber. Due to the low pressure zone, the suction fluid will start to move toward and mix with motive fluid in the mixing chamber. In mixed fluid, enter the diverging portion of the ejector where its velocity energy is converted into pressure energy. The main function of the ejector is the condensation system of the turbine. Simply, steam ejectors are used to create a vacuum within a system. This is done by injecting water or steam into the system at a high pressure and velocity, which causes the air or other gases inside to be expelled from the system at a high velocity as well. The principle of operation for a steam ejector or steam injector system is based on Bernoulli's principle. This states that when the velocity of a fluid increases, its pressure decreases. There are two types of ejectors: single stress ejector and multi-stress ejector. The simplest single stress ejector featuring a single motive fluid nozzle, diffuser and mixing chamber. On the other hand, multi-stress ejectors combine multiple single stress units in series to achieve higher vacuum levels. A healthy sewage ejector pump runs quietly in the background. If it is heard grinding, rattling or humming or feel vibrations through the floor, that is a strong indicator of internal damage. The motor or impeller may be worn, loose or obstructed. So at that time we need to maintenance the ejector.
This is power plant ejector unit. You see, it is nameplate. What are these ejectors? And here is 2 number ejector. This is one unit and that is another unit. And you can see this is the water inlet line. Here is the ejector arrangement. Water passes or enters through this line, and here is a arrangement, then water passes through this line and then overflow and then drain through this line, and the vacuum, that is gases, comes from turbine through this line and then it passes through this line and then create vacuum. Here is two ejector, you see that one, and here is a one and the parallel line, and here is also a transmitter. You can see this is the pressure transmitter. Here the vacuum negative, that means minus 89.59 kPa, because the turbine is running now. And you can see this is the turbine line, this one, it is connected with the turbine. You see this line, we will follow this line from another side, from that side. This side another transmitter is connected. Here a vacuum showing minus 84.96 as like 95 kPa vacuum, and its connection, you see this is the cable connection and here is the line connection. This side right here is the water pot and this is the line, vacuum line, and this is connected to the turbine part. And from here we can also see the vacuum, and the ejector is connected to that side, and we change the ejector diaphragm. At first we need to change this part. Here we need to open the bolts and then this part is open, and here is the diaphragm position. And also the pressure gauge is not showing the accurate reading. Here is some problem, I think. When we start the water pump, then here a pressure arise and likely 3 to 4 kg per centimeter square, and here we change the diaphragm in different lines and different shapes, and we followed the vacuum from the transmitter as well as our DCS system, and then after finally the vacuum is sufficient, that means as like more than 85 kPa, then we thought that the vacuum is okay, and then finally we keep the diaphragm position adjusted, and the working procedure will describe clearly. By observing this video, you can see how we have measured the diaphragm position and also resolved the vacuum problem. We will see the ejector pump also. Here is the ejector, and we will see the pump of the ejector. Here is 2 numbers pump. One is running, this one, and another is standby. This is the standby pump. If any problem create to a pump, then we change the pump. And you see, here is the suction line. This one suction line from this chamber or vessel, and then here is the parallel connection, this pump and also this pump. Then water comes to this line and then pump through this line, it goes to the ejector unit. This is ejector unit, and from the ejector there is the delivery line. You see, a green line These two green line, this is the drain line of the ejector, and this drain line is connected to this vessel, and this vessel level and temperature is maintained. If his temperature is somewhat higher, then fresh water is added by suction valve. Here is the running the pump. If any time to check the pressure, also we change this pump, and also we maintain the pressure. Here is 2 number transmitter. This is also the valve. This is drain valve. This valve is closed, and here is the transmitter. You see, this is the pressure. Here is 0.34 ampere. That means 3.4 kg per centimeter square pressure of this pump, that is ejector suction line pressure. And in this way, by flowing water by this pump and through this ejector unit, we maintain the vacuum of the turbine to run the vacuum, to keep the vacuum perfectly and to smoothly run the turbine. And here is from the upper side, we saw the vacuum line. This is the line here to the upper side. That line, you see, this line.
Now we will see how we have selected our diaphragm and modified. Here is the picture. This is the diaphragm. We test basis done this, and finally we came to a position how we will select the diaphragm hole. Here, this is the diaphragm. At first we make a scratch, that is, here is only a scratch. This is the bolt to connect the diaphragm to the ejector, and only here is a scratch, and after that, connecting all things, we saw that the turbine vacuum is likely 22 to 25 kPa. After that, again we opened the ejector cover and then make a hole in the diaphragm. Here you can see, make a hole in the diaphragm, and after that we tested and measured that the vacuum values 25 to 28 kPa, and this is not our requirement. Our requirement is likely approximate 90 kPa. And then after we make a hole, likely 4 numbers hole, the 4th side of the diaphragm, and we measured the vacuum is likely 55 to 62 kPa. It is somewhat lower value, so again we changed, and before this we make 3 numbers hole before 4 numbers. When we make 3 numbers hole and then after measure the vacuum, then we got 72 to 73 kPa, but our requirement is likely 85 to 90 kPa. So then we make double hole to the 3 sides. Here is 2 hole, and upper side 1 hole. That means total 7 number hole. The hole diameter is likely ½ inch, and followed that vacuum is 64 to 65 kPa. Finally we measured, then here like this the diaphragm, 3 hole and a scratch. In this position we started again, box up the ejector and then measured, the vacuum value is 79 to 82 kPa, and in this position when we charge steam and then vacuum goes to 87 to 91 kPa. So finally we kept this whole modified system of the diaphragm, and the ejector is now functioning okay, and turbine vacuum is okay, and it is likely 87 to 91 kPa. In this way, after test basis, we finally came to a position how we modified our required vacuum to run smoothly the turbine. Here the ejector, we opened the upper cover and observed the pipelines or ejector inside, and we also followed how the ejector works. This is the inner side, and here inner side we followed iron particle. You see, this is the inlet of the water flow line. This is ejector unit, and also one of the ejector, its base was damaged due to corrosion, so we changed the ejector by new one. But the new ejector, its connecting pipe was somewhat different from the used one, so we have to some works to connect this new ejector. The ejector was not functioning properly, that is, its vacuum was not came to required value. Our lowest value, that means vacuum needed, is more than 85 kPa. So we opened this ejector. This is the complete unit. This complete unit we changed. You see, this is the old one, and here is it's damaged also. By scanning, we measured by our sensor inside this ejector and followed that some damaged and corrosion. So when we changed the new ejector, also we changed this line. Here is the, we saw inside value by boroscope. Also here is some leakage. Here is a hole. We opened the ejector lower part. This is the lower part, and we changed this part. By ejector, appropriate vacuum is done to run the turbine. This is the old ejector inside. Here its body is corroded. You see, somewhat corroded, and for this we changed, replaced the ejector by new one. This is the new ejector unit. We will install this, and this size is not properly as it likely the old one. This is the diaphragm, and this is transmitter which shows the vacuum. Here we will connect the ejector, so we need to put a diaphragm here. It is cleaned, and liquid gasket putty hardener. We mix here, you see, mix this, and then it will be used here. properly seal its vacuum inside the ejector, and on this putty gum here somewhat a hole, so we put here the hardener and then put the gasket here, and on this upper side we will put the ejector. This is rubber gasket for water line. To put the ejector on its base, and you see this is the lower side. This is connected to the lower side water tank, and this is somewhat different from the old one, so it is needed to connect. So we cut this and then welded for proper connection. After completion of the maintenance work, we run the pump, ejector pump. We followed here the pressure, you see 0.03 approximately. This is the suction pressure, and also we followed from our DCS panel. We followed this is the vacuum -30, 29, 30 kPa. This should be likely approximate 85 to 90 kPa. So after doing the work, we followed from DCS also and from local transmitter also. Here the diaphragm was not accurate, and somewhat we followed that the vacuum is 66 -66 kPa in different position. That is, the diaphragm hold different position. We measured the vacuum. This is value from transmitter, 62 kPa minus, so it shows vacuum. The transmitter is two sides. This is the ejector directly connected, and this is also connected to the turbine. So turbine side somewhat lower valued, put to 5 kPa, and also in this way we change the different position its diaphragm. Here this is the ejector unit. This is the spring. One of the spring was damaged. The spring was not functioning. Also we changed this spring and checking the spring is functioning or not. Here we need to set the diaphragm. Initially we only ran a scratch and then connected this diaphragm to the ejector and followed. The vacuum was only 22 to 25 kPa. Then after we again opened the ejector. Here you see here is 7 numbers hole, and the vacuum was likely 64 to 65 kPa. After that again we changed the diaphragm. Here also from DCS lower valued vacuum. This is the suction pressure, and this is the pressure gauge of the connected to the ejector. Here also opening the vacuum line, we also checked the vacuum is stating or not by pressing our hand. Here should be set the diaphragm. diaphragm is to be set on this part. This is the diaphragm. Here also you see, here is different diaphragm, a 2 numbers hole. This is the final modification stage of the diaphragm, and in this way we completed our works and the vacuum system is okay. Thanks for watching this video.